Hello students, today we are going to learn about propagation of electromagnetic waves. You have already learned what is an electromagnetic wave, right? But suddenly you may think now we are learning about communication system and why we are here to learn about the propagation of electromagnetic wave, right? Just think about the mobile phone. Is it a wired thing or a wireless thing? Because using a mobile phone, you can communicate to a person who is in New Zealand or in Australia or in US or anywhere around the world, right? So basically, we all know that mobile is a wireless thing. Then how the signals are received or transmitted by a mobile phone? So it basically happens by the propagation of electromagnetic waves. So the wireless communication basically happens by transmitting the signal in the form of electromagnetic waves, right? Okay. Now let's understand in what manner or how these electromagnetic waves are transmitted from one place to another. So basically the electromagnetic waves are transmitted using space communication. Space communication. So what is space communication? Space communication is nothing but transmitting or receiving what? Information from one place to another in a physical space medium. So what is space communication? As we have already learned in communication, we are transferring or receiving information. So transmitting or receiving information from one place to another in a physical space medium is called space communication, right? So basically space communication is nothing but which happens on the surface of earth or space, okay? So that is called as space communication. This space communication can be mainly classified into three main types, that is ground wave, sky wave and space wave propagation and space wave. So we can propagate electromagnetic waves using a space communication in three main different ways, that is ground wave propagation, sky wave propagation and space wave propagation. So basically these are the three main types of propagation of electromagnetic waves. So before going and learning about these three types of propagation in detail, let's understand space communication. What is space communication? What is the range and what are the factors of space communication, etc. So in this space communication, the information is transmitted from one place to another is by using electromagnetic waves of high frequencies, which is called as carrier waves, which means the frequency range is from 10 raised to 4 hertz to 10 raised to 11 hertz. This will be the frequency range of an electromagnetic wave, which we are transmitting using space communication. So as I have already told, we can transfer information from one place to another with the help of electromagnetic waves. When we are using electromagnetic waves, there is no need of any wired thing. We can use wireless thing. Because of this space communication, you can even imagine how fast our life is moving on. For example, mobile, in where we are sitting, we can find out anything around the globe, or even we can find out what is happening in space as well, right, by using a small mobile. So basically, space communication is used in radios, television, satellite communication, etc. So these are the major places where we are using or where we are taking the help of space communication. So before winding out, let me just tell you what is space communication, what are the different types of space communication, or how we are transferring information using space communication is by using these three different ways, that is ground wave propagation, sky wave propagation and space wave propagation. In space communication, we can transfer frequencies from 10 raised to 4 Hertz to 10 raised to 11 Hertz. Mainly we are making use of space communication in radios, televisions and satellite communication. So now let's understand what is ground wave propagation first. So ground wave propagation, it's nothing but from the word ground wave propagation itself we can understand that the radio wave or the electromagnetic wave is getting propagated through the ground, right? So ground wave propagation can be defined as the radio wave which is propagated from the transmitter antenna to the receiver antenna directly in the ground or in the earth surface is called as ground wave propagation. So as I have already explained, ground wave happens in the surface of ground. Because of this, the receiver and the transmitter should be very close to each other, or else there will be a very attenuation, which means there will be very loss of signal strength. So in ground wave propagation, the important factor which we all have to remember is the transmitter and the receiver should be very close to each other. Receiver should be very close to each other. This is the first point which we have to remember when we are learning about ground wave propagation. Now the next thing is, as I have told, ground wave propagation happens on the surface of earth, right? And the transmitting antenna as well as the receiving antenna should be very close to each other, which means it happens on the surface of ground, which means there will be a chance of attenuation if we are sending a very high frequency. So in ground wave propagation, only low frequency signal can be transmitted. Low frequency signal can be used. Okay, so what is ground wave propagation? Transmitting information from one point to another using radio wave, and it will be getting propagated through the surface of earth or of the ground. And in our ground wave propagation, the transmitter and the receiver should be very close to each other. And the other thing which we have learned is only low frequency signal can be transmitted in a ground wave propagation. Now let's discuss the advantages and disadvantages of a ground wave propagation. What will be the advantages of ground wave propagation? If we give enough transmitting power, by using ground wave propagation, we can transfer information between any two locations of earth. So by using ground wave propagation, we can by giving a proper transmitting power, we can transfer information between any two locations on earth. That is an advantage for ground wave propagation. Next is, ground wave propagation is not relatively affected with the atmospheric condition. So these are the main two advantages of ground wave propagation, that is transmitting power we can transfer. If we are giving a proper transmitting power, we can transfer information from one point to another between any two locations on the earth. And the next one is it is not affected with the atmospheric conditions. These are the advantages of a ground wave propagation. So what will be the disadvantages of a ground wave propagation? Yeah, as we have already discussed, the main disadvantage for a ground wave propagation will be as its frequency is limited. In order to transmit a very high frequency or MHF, then we need very large antennas. If you want to transfer VHF or MHF, then we need a very large antenna. Next will be what? Next will be the same thing. Here we have told the transmitting power. If we are giving a proper transmitting power, then we can transfer information between any two locations, right? Which means a very high transmitting power should be there. Very high transmitting power needed. Okay, so these are basically the advantages and disadvantages of a ground wave propagation. So now we understood about ground wave propagation. Next propagation method which we are going to discuss is about space wave propagation. The main important thing of space wave propagation is the receiving antenna and the transmitting antenna should be in the line of sight. We'll write it as LOS. LOS means line of sight, which means here the radio wave which we are propagating will be going from the transmitter directly to the receiver. If in between any barrier is there, the signal won't be reaching the receiver end. The signal from the transmitter will be directly reaching the receiver. If the signal from the transmitter is directly reaching the receiver, then we can say that the method of propagation of radio wave is space wave propagation. Line of sight. You might have wondered what is line of sight, because actually this is a very new word for you, right? Line of sight is nothing but it's very easy. Just think you are in a room and you switched on the light. So if there is a wall and all the four walls are closed, there is no way for the light to go out, right? So if there is no place for the light to go out, it won't be going out, which means there is a barrier. Same like that, the signal, if there is a transmitter and a receiver, and if there is any barrier in between, then the signal won't be reaching the receiver end, because by hitting that barrier, the signal will be going somewhere else. It won't be reaching the receiver end. So always the transmitter and the receiver should be on the line of sight. So in space wave communication, the transmitter and receiver should be on line of sight, which means the information which is transmitted from the transmitter should directly go to the receiver. There should not be any barrier between the transmitter and the receiver. Such kind of propagation method is called as space wave propagation. So one thing we can say that there is a limit or how much distance this signal can be traveled, right? Because it is a line of sight communication. Here we cannot say that it will be, obviously it can go very far as well, but how much? So let's find out the range of space wave communication. So the distance which we can send a signal using space communication is, range of the radio wave will be root of 2HTR, where HT will be the height of the antenna, and R is the radius of Earth. Radius of Earth. So this is the range wherein we can transfer space wave communication or space wave propagation. The next mode of propagation which we are going to discuss is sky wave propagation. From the word sky wave propagation itself, it's very easy to understand. We are making use of the sky to propagate the electromagnetic wave, which is what we are doing is, the transmitter will be over here and the receiver will be very far away. Let's say it's over here, but the distance between the transmitter and the receiver will be very far away. So, first we have learned about ground wave propagation. In ground wave propagation, we have learned that the transmitter and receiver should be very close to each other. So, here it is very far, right? Then we have learned about space wave communication, where we have learned the transmitter and receiver should be in the line of sight. Now, I am saying why we are going to make use of sky is, if the transmitter and the receiver is being kept very far away place, it's been kept at two different points on the earth. So, it cannot be used, or we cannot transmit the signal by making use of ground wave propagation, as the distance between the transmitter and receiver is more. We cannot make use of space wave communication, or space wave propagation, because the transmitter and receiver, we cannot assure that it will be on the line of sight, because as the distance increases, there can be a tree in between, there can be a building in between, there can be anything in between, right? So, that in this case, we cannot use space wave propagation as well. So, the next step is the sky wave propagation. What happens over here is, we will be making use of a layer of the atmosphere called as ionosphere. So, in this case, the transmitter will be sending a signal, and it will be going and getting reflected from the ionosphere and will be reaching the receiver. So, the signal will be going in such a manner that it will be going and hitting the ionospheric layer of the atmosphere and will be received by the receiver. This mode of propagation is called as sky wave propagation. So, we have learned all the three modes of propagation wherein we are using space communication or space wave communication. That is, we have learned about ground wave propagation, we have learned about space wave propagation, and even we have learned about sky wave propagation. And we know the basic use of this modes of propagations are the luxury which we are enjoying now. For example, you are watching a live match which is happening in Australia, right? Or you are hearing the speech of a Prime Minister who is addressing the Indians over there in Australia or in America. So, this all happens by these modes of propagation.